Okay, we've already kind of mentioned this before, but if you forget, let's review. What is a series? We're going to be adding all the terms together. So it's the sum. So a series is when you're actually summing the sequence together. And you can recognize a series because it's separated by plus signs or minus signs. Okay, depending on if your common ratio is a positive or a negative. If it's a negative and you're going down, it's going to be separated by minus signs. If you add those, if you add a negative, it's like subtracting. So S of n is the sum of the first n terms. Find S of 5 for the above series. So if I want S5, so instead of T, we're using S when we want the sum. S stands for sum. Pretty logical. Yes, can you? I don't know. 1 plus 3 plus 5 plus 7 plus 9. Let's add those together. So easy way to add this. 1 and 9, 10. 7 and 3 is 10. Plus 5 is 25. So that's the sum of the first 5 terms. Okay, notice the difference between S5 and T5. This is T5, the 5th term. S5 is 25. It's adding all those 5 terms together. That's a series. Okay. Okay, for the sequence, 3, 7, 11, and 15, find the general term. What does general term mean? We need the common difference. What else do we need to get the general term? T1, we need our first term. When we're making the general term, we want to make the equation, the formula. Okay, so what is the common difference for this one? What are we adding? 4, what's the first term? 3, so this should be child's play, right? Especially after that quiz. So much easier. 3 plus n minus 1 times 4. You could leave it like that unless the question asks if it was written, I say to simplify, then you have to bring in that 4. Get to distributive law. Four n minus 1. You always can check your general term, your formula, by just plugging in your n values. So if n was 1, do I get 3? 4 times 1 minus 1, yeah, that's 3. If n is 2, do I get 7? 4 times 2 minus 1, yeah. So you can always double check that you have the right formula by just plugging in the different n values and seeing if you get the same terms. That's a check. Find the sum of the first 4 terms. What are we going to do? Just add them. 3 plus 7 plus 11 plus 15. What does that give us? 36. Yeah, 10 plus 6, 26. 36. In order to find the sum of the 8 terms, what would we have to do? Just continue the sequence. Okay, what's after 15? 19, 23, 27, and 31. Okay, we already know this, right? Is 36? Yes, great. Okay, so now we have some fun. This here is 50. Did you just add it up in your calculator? That works too. Or I could also then add those together. Those are 50. So I get 136.
I have the next 10 grade 10 students. Last 3 numbers 057 all the way to 066. 057 to 066. Please come down to the office now.
Okay, 136. Now what if I asked you for S50? Is it possible that you'd make a mistake trying to figure out all 50 terms and adding them together? Yeah. Is there an easier way to do this? Yeah. And we're going to learn about that today. I'm going to show you how the formula is derived, okay? Yay, you love deriving formulas, don't you? Favorite thing in the world. So this is this the same sequence? No, a different one. So a different sequence, and I want to find the sum of the first 7 terms. So my first mistake here is I should have plus symbols, not commas, because I want to find the sum of the first 7 terms. So I'm going to do something. What I'm going to do, and this kind of relates back to linear systems in grade 10. Would you agree that the sum of the first 7 terms is the same thing if I write it backwards? Oops. 20 plus 17 plus 14, 11, 8, 5, and 2. Is that still the same thing? Yeah, so what we're going to do is we're going to add these together. What? Oh my gosh. We can add equations together. You did that before. Okay, so how do I do that? S7 plus S7. If I have 2 sums, it's equal to 2 sums. 2 S7s. An S7 plus an S7 is 2 S7s. Now I'm gonna add each one of these vertically. What do they all add to? 22 plus 22 plus 22. How many times? 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. So instead of writing 22 plus 22 plus 22 7 times, instead I could actually write that as 22 times 7. Actually, can I write that as 7 times 22? Does it bother you if I do that? I'm just trying to make it more like... Okay, so what's so special about the 7? The 7 was how many terms we had. Agreed? That's our n value, the number of terms. What's so special about the 22? Would you agree that the 22 is the same thing as the first term? Let's just write it. I'm going to write first plus last term. The first plus the last term. Would you agree with that? The first plus the last? Yeah? First plus the last? Okay, good. So we basically derived the formula because I don't want 2 sums, so what's the last thing I would do? Divide by 2. So divide by 2, and there's our answer. 7 times 22 over 2, which equals 7 times 11, 77. Okay, so why do we do that? Well, that's our formula. Okay, our formula for finding the sum of n terms is equal to, so instead of 7, this was n, right? The number of terms. And I'm going to put the over 2 over here, times the first plus the last. Oops. Plus the last. Okay, so this is n over 2, n over 2. And then the 22 was the first plus the last. There it is, it just derived. Done. We made a formula. We are amazing. Great. And you go home today and be like, I made a formula today. So this is a great formula. It's a great formula in what cases? If we know, you have to know your number of terms. What else do you have to know? First term and your last term. Uh-oh, what if we don't know our last term? We don't always know our last term, right? We could figure it out, or we can derive another formula. Do we have a formula for T of n? Yeah, what is it? It's T1 plus n minus 1 times d. Okay, this here is the formula for T of n. Yes? Oh, so if I T1 plus T1, can we simplify that? 2 T1s plus n minus 1 times D. Okay, you should be able to derive this on the test. I'm just kidding. You don't have to derive it. Because guess where it is? 4. It's right in front of you. You have your formula sheet in front of you. So here they are, the 2 ones. So if I know my last term, if I don't know my last term, but I do know my common difference, here's the other one. Done. Okay, so let's try using these. Look at the next page. Pretty cool? So this is everything we just talked about. So we can go straight to our question. Here's some notes there. What everything stands for, right? So this question says find the sum of the 45 terms in this sequence. We have 2 formulas. The easy one and the hard one. Which one can I use, the first one or the second, or do I have to use the second? Can I use this one? This formula here. Can we use that one? So what do you have to know to use that formula? You need to know your number of terms. Do we know our number of terms? 45. We have to know our first term. Do we know our first term? Yep. Do we have to know our last term? Do we know our last term? Yeah, we do. They tell us right there. That's your last term. So if it actually ends with a number, not just dot, dot, dot. See here, example 3, the next example just has dot, 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 and then no number followed. That's an example where we don't know our last term. This case, we do. So we are so lucky. We can find the sum of our 45 terms and just plug it in. N divided by 2, that's my n value, 45, times the first plus the last. There it is. Let me grab my calculator. There it is. Okay. So 45 divided by 2 times 30 plus, the negative is below the 3. You have to use the negative symbol there. Negative 3,600. Do you get the same thing? I hope so. No one's arguing with me, so that's good. Next one, find the sum of the first 21 terms. What do we know? You know your first term?
I have the next 10 students come down to the office, please, for timetable changes.
Okay, what else do we know? Do we know what our common difference is? What are we going up by? Positive 4. We're actually adding 4 each time. Good. What else do we know? 21. What does 21 stand for? And your number of terms. Do we know our last term? No. We have to use the other formula, the ugly one. Okay. So why don't you find out the sum? Sub it in, find it out. I need to make this bigger. Is that better? For some of you at the back, I know it'd be hard to read. When I'm punching in my calculator, what I would do, so I don't make a mistake, I would actually just go 20 instead of 21 minus 1. I can do that math and know I'm not going to make a mistake, right? So when I type it in, I have 21 divided by 2 times, then I could just go 2 times negative 11 plus, instead of 21 minus 1 in brackets, I'm just going to go 20 times 4. A little safer. 609. So make sure you can get the same thing. Okay. Okay? Manageable? Not that big of a stretch from yesterday's lesson, hey? 2 new formulas, but they're not that bad. Find the sum of the arithmetic series. Can we go on? Oh, did you not get 609? Did anyone else? Did you not? No? No? Everyone got a different number? That's 609? Okay, so it could be a bracket issue when you're typing it in. If you're typing in the whole thing, make sure you're putting negative 11 plus, if you do the 20 minus 1 or 21 minus 1, it has to be in brackets times the 4, and then close your brackets. But closing that last bracket too is important. You should get 609. If not, after the lesson, ask me and I'll figure out what you're doing wrong. Okay? Because you should have 609. Find the sum of the series. Term 1 is 5. Common difference, 4. Good. Okay, what else do we know? The last term, t of n. So can we go straight to using s of n equals n over 2 times t1 plus tn? No, why not? We don't know our number of terms. How many? Darn. Now what? Is there a way that we can find the number of terms if we know the last term? T of n equals term 1 plus n minus 1 times d. We have to go back to yesterday's stuff and sub in what we know, which we have here to the side, and find n. T of n is our last term. First term is 5. N minus 1 times 4. Okay. So distribute the 4, solve for n. Four times n is 4n. 4 times negative 1, negative 4. So 5 minus 4 is 1. What's our next step? Minus 1. Good. Now we have 200 equals 4n. Next step. Divide by 4. What do you get? 50. Now can we find our sum? Yes. You don't have to use the second formula. We can use this first one because we know our last term. So 50 over 2 times, our first is 5, our last is 201. 25 times 206. Or you can type it in, 50 divided by 2 times 5 plus 201. 5150 or 5,150? I guess I am a math teacher. I should pronounce it right. Okay, we're almost done. I think we're almost at the point where you could try some homework. Let's see what I still have to see what's here. Let's see. Under terms. Example 5 is straightforward. You know your n, right? You know your first term. You know your common difference. So we're going to skip number 5. Did you want to? Can we skip 10 or 6? I mean. So again, just looking quickly at 6. You know your first term is 2. You know your common difference is 2. What else do you know? Your n. Remember the little number? The subscript? Is that the right term for it? I'm Englishies. Yeah? Is that right? Subscript is 10. Okay, that's your n value. So you'd have to use the second formula. That's all. You'd have to use this, the second one. 2t1s plus n minus 1 times d. So we're going to skip that. Do you want to try, let's do 7 or 8. Pick one. Look at 7, look at 8. Tell me which one you think looks harder. Let's solve that one. 8, 7. 7. Okay, who says 7? Flip your hand. Okay, who says 8? Well, no one wants to say 8 anymore? 8 is actually really similar to what we did yesterday, right? We have a multiples question yesterday. So it's actually nice. 7's, let's start with 7, and then for those of you who really want me to go through 8, I can do that. The rest of you could start your homework, okay? I can't read that. Too big. Student allowance of $5. Man, that's inflation for you. I used to get like 50 cents. Gets an allowance of $5 in the first week of the year. Each week, her allowance goes up by 50 cents. All right, so when I see a word problem, guys, like this, what you want to do is generate a sequence. Actually make the sequence. Don't try and jump into the formula. Make some terms, because you don't want to make the assumption like you did. Remember yesterday when you're like, oh, the multiples of 3? Like in your head, you think, oh, multiplying by 3, so I must be geometric, but it was actually arithmetic. So generate those terms. First term is what? 5. What's the second term? 550. 6. Okay. That wasn't so hard, was it? So now looking at it, we know our first term. We know the common difference is 0.5. And this first question says, what is her allowance in the last week of the year? N is 52. So there's 52 weeks in the year. Now, are we summing the terms together? Am I looking for S of 52 or T of 52, term 52? Term 52. We're not looking for the sum of all her allowances. We're just looking for how much money did she get the last week. T52. So this should be straightforward. Term 1 plus n minus 1, so 52 minus 1 times 0.5. If you want, you can go straight to just 5 plus bracket 52 minus 1 times 0.5. $30.50. Now that's some serious inflation. That's what we need to have. That needs to happen to our Canadian dollar. It needs to go up. We need it. Okay, now B. How much money did she receive in the first year? Now what are they asking for? Total money, the sum of all the money she accumulated. Oh, not 50. How many days? Or how many weeks? 52. S52. Can we use our first formula? Yes, because we know the last term. First term plus last. Okay, so 52 over 2 times, uh-oh, turn off your volume. 5 plus, my last term is $30.50. If you can calculate that, that'd be great. Use your calculators, punch it in. Work out those fingers. What do you get? $923? Is there 50 cents or no? That's it? 923? So if she saved, $5 didn't seem like much in the beginning. Go far. Okay. How much money would she receive in 3 years if it still increases? So this time, how many weeks would that be? If it's 3 years, 156. Are we looking for T50 at 156 or S156? S156. Okay, it's important that you find the full 156. You can't just say, oh, how many more do I need? Because it won't give you the proper sum. Try to just do like S, I don't know, 156 minus 52, just the 2 years. Because it's growing every year. You have to do it from the beginning always. Do we know the last term? Do we know how much she's getting? No. So we have to go back to the other formula. 2 times our first term plus n minus 1. Oh, not 50, 150. What is that supposed to be? Yeah. Thanks. 156 minus 1 times 25. Okay, so I would like you to type that in and make sure you get the same answer.
10 students for timetable changes.
If you just quickly turn to the last page, if you want to start your homework, you can. What I will mention about example 8, we did do a question just like this yesterday. Again, generate some terms. How many multiples are between 10 and 400? My question for you is, would 10 be your first term? No. Why not? 10 is not a multiple of 3. So how many multiples of 3 are there between 10 and 400? What's the first multiple? 12. The next multiple would be 15, 18, all the way to, what's your last multiple? Is 400 a multiple of 3? You can check that by going 400 divided by 3. Is it go into it? No, so then I'm going to go to the next one below it. Is 399 a multiple of 3? Yes, so that would be your last term. Okay? So this question we're solving for what? How many multiples? Maybe we should do this question. Yeah? Yeah? So what is n? We're going to use our last term is 399, right? First term you'd use as 12. Common difference would be 3. Last term 399. And we're looking for what term number is 399. Then you know how many multiples. Okay? And then last is finding the sum of them. So it's really, once you know your n, it's straightforward, right? So can I leave it there? Is that okay? You guys can handle, we did a question just like this yesterday. So solving for n now. We've done that many times. Okay? Odd ID. I'm going to stop this.